it works. We started out with how to approximate it based off rectangles, and then we started doing the limits as the number of the rectangles went to infinity, but it's time consuming. And there is actually a more efficient method for finding this, and it's what's called an integral.
No, I have a way of
He's okay with it?
Yeah, it should be.
So, when we talk about an integral, it's going to be a tall, skinny looking S thing. And we will have, it's a definite integral because we will have a starting and a stopping point, just like we might have found the area from A to B or from 1 to 3 of a function is the same thing as doing the limit as it goes to infinity of the sum from 1 to n of your f of x sub I times the change in x that we were doing on the homework 2 days ago, and we had one on the quiz yesterday. This dx represents the change in x, so that's the same as that change in x. F of x is like your f of x sub I. This integral symbol takes the place of the limit as n goes to infinity. In this, notation-wise, f of x is what's called the integrand. It's the thing we are doing the integral of. A and B are the limits. So A would be the lower limit, or the starting point. B is the upper limit. Or that ending point. Something to note, anytime you have this integral symbol, you will have that dx with it. Those go together. One of them without the other one has no meaning. So you always have both parts of that. Questions so far? So when we do this, that definite integral is just another way of adding up all the areas under the rectangle. So it is another way of finding the area under the curve. One thing that we haven't looked at is sometimes we know curves go below the x-axis, right? And all the ones I've given you were above the x-axis. So we will have to consider things above the x-axis are considered to be a positive area. Things below the axis are a negative area. If I want, when I'm calculating the integral, it's really finding the net area. It automatically will take, the positives and subtract off the negatives. So we're not going to have to do anything fancy here. The integral does take that into account. But it would be possible to find an integral, find the area under the curve, and get 0 if it's the same amount above and below the axis, or to get a negative answer if it's below the x-axis. So I don't want you to think that the area always has to be a positive in this scenario, because below the axis will be considered a negative. So we need to be able to go back and forth between the two. So we are going to start with the problems that we have been doing in the past. What we've been doing is what's called a Riemann sum when we do this limit as n goes to infinity of the sum from 1 to n. So I want to do one of those first. So like what we were doing to end the last section. So the difference is how I asked this question. I gave it to you in interval notation, or I'm sorry, in integral notation. And I need to turn that back into what we were talking about before. So when we did those problems before, we had to have a change in x, and we had to find the f of x sub I. Change in x was always your ending minus your beginning divided by n. Where is my ending point? The top, so that would be 4 minus, we began at 0 divided by n. So we get 4 over n for the change in x. How did we get the x sub I?
Four over n.
We had to, I guess first, let me write out x sub I, is our starting point, which is 0, plus the change in x, 4 over n, times I. And that would just simplify into 4 over n times I, right? So then to find my f of x sub I have to plug that into the equation. So I have to go up and change each of those x's in the original function to a 4 over n times I. 4 over n I cubed means 2 times 4 over n I. If I simplify that, 4 cubed is 64 over n cubed I cubed minus 8 over n times I. So, an integral, if you use that definition I gave you, says it means the limit as n goes to infinity of the sum from I equals 1 to n of f of x sub I times the change in x, which was 4 over n. The board appears to have a delay in it today. Have I lost anyone? So really, same type of problem that we were doing to end the last section, but I changed how I asked the question. So we had to be able to understand what that integral meant in order to rewrite the question into what we're used to. So now, we need to simplify this. So if we distribute 64 times 4, 256 over n to the 4 I cubed minus 32 over n times I. So now we have to use our summation rules. So the 256 over n to the 4th, that's just like our coefficient.
Would that be n squared?
Thank you. Times, what's the formula for I cubed? Remember, I cubed is like the I formula, but if you square everything. So it's n squared times n plus 1 squared over 4. You will have to have those formulas memorized. What's the I formula? Times n plus 1 over 2. Okay. So we need to clean this up as much as possible. I could cancel this n squared. N plus 1 squared would turn into n squared plus 2n plus 1, right? 256 over 4 gives me a 64. So then I distribute 64n squared plus 128n plus 64 this should be an n squared on the bottom. It was n to the 4th and I wrote it cubed when I wrote it down, so that's n squared. Find this. Over here we can cancel one of the n's. 32 divided by 2 is 16. That would be 16n plus 16 over n. Okay, so if I reduce this, we get 64 plus 128 over n plus 64 over n squared minus 16 minus 16 over n. All right, now we can do our limit. If n goes to infinity, everything with an n on the bottom drops, turns into a 0, so we're left with 64 minus 16, or 48. So far this is just more practice with what we did before. I just gave you the original problem in integral notation instead of stating it in words. So we found the area under the curve, x cubed minus 2x, between 0 and 4, right there. Questions on that one? Okay. So we're trying to get comfortable with both notations and going back and forth. So if I asked you to write this as an integral, I'll give you a second to write it down since I failed to print for you. So we're going to have the integral symbol, that's the skinny looking s, and if you have that, we need to put our limits. What is our lower limit? And the upper limit would be 2. Okay, then we put our function. In the integral, basically you just don't have any subscripts. Your x sub I or x sub I plus 1 or whatever it might be is just going to turn into an x. So it's just 2 minus 3x. And what do I change when I see the change in x sub I, what do I have to put for that? Dx, when you have an integral, it'll always have a dx at the end. So that's what it would look like as an integral.
So I never matter.
No, not when, basically in the summation formula you have the subscripts with the i's, but in the integral itself you don't. Alright, so let's do another example of each type. If I ask you to evaluate this integral, so that's like the previous one. So if I give it to you as an integral and ask you to evaluate it, we have to change it to the summation form so that we're able to use our rules to calculate it. So if I'm going to change it to summation form, we need our change in x. How do we get the change in x? Five minus 2 over n, so that's 3 over n. X sub I is your starting point, which we started at 2, plus the change in x times I. So when I find f of x sub I, you're going to the function and you replace your x with this x sub I. Do you guys want to leave it like that, or do you want me to go ahead and multiply it out? Go ahead and boil it up, would that be okay? Alright, so that would be 3 times, if I squared that, I have to FOIL, so it would be 2 plus 6 over n I plus 6 over n I, 12 over n I plus 9 over n squared, I squared. So 3 times 4 is 12, plus that 4 is 16. So far, so good? So now, when I go to rewrite the integral is the limit as n goes to infinity of the sum from 1 to n of, we replace our function with the f of x sub I, which we have simplified to this. My board is delaying, so if I write too fast, it just turns it into a line today. Times, what do I replace the dx with? Change in x, which is 3 over n. We distribute. So now we can do the summation. What happens if you add up 48 over n times? What do you have to do with that? So that's 48 over n times n. plus 108 over n squared times the formula for I is n times n plus 1 over 2 plus 81 over n cubed. What's the formula for I squared?
N times n plus 1
This is really just a lot of algebra to simplify this stuff. 48 over n times n. 48 plus. Right. You can cancel one of these n's. 108 divided by 2 is 54. So that will turn into 54 n plus 54 divided by n. Cancel one of those n's. 81 and 6 equals to 27 over 2. Am I going to do too much if I FOIL these before I multiply it out? So that's 2n squared plus 3n plus 1. So if I distribute the 27, on the bottom I get a 2n squared. So if I break apart these fractions, 54n over n is 54. 54 over n. 54n squared over 2n squared is 27. 81 over 2n. And 27 over 2n squared. So now we can finally do the limit, and anything with an n on the bottom turns into 0. So we get 129. Okay, the area under that curve. Neatness is going to be pretty important here. We've got a lot of things we're multiplying together. You know, gotta watch your signs, gotta watch your coefficients. So please make sure you're writing things out and it's legible. I'd like to do one more and then I'm probably going to stop for today. So this one I just want to do another one like example 2. Just practice writing the integral so that we've really just done 2 types of problems today. For the integral. So the limit as n goes to infinity of the sum from I equals 1 to n, that all gets replaced with the integral symbol. Where do we start?
0.
And end at pi. Okay, in here, all of those x sub i's just turn into an x. So it's x cubed plus x sine of x. You might see, instead of an X, sometimes it might have an M. And that is something we're talking about Monday. It stands for midpoint, but it's the same thing. If you see that M sub I, it just gets turned into an X. And then change in X, what do we replace that with? Dx. So that's our integral. So, there is a handout posted on Classroom. This is for today and Monday combined. On this handout, you really know how to do 1 through 5 and 10 through 14. 1 through 5 is just writing the integral. So like these examples 2 and 4. 10 through 14 is when I give you the integral and you have to